Okay, sir. Greetings, everyone. Today, the students of University of Petroleum and Energy Studies, will be presenting a case study on Boeing avionics, Boeing 747 avionics architecture. Basically, it will be a general overview of the avionics architecture of the Boeing 747 series. Today, me and my fellow classmates, Bhaumik Tiwari, Ashwin Xavier Francis, and Janvi Bhatia will be presenting the presentation.
Talking about the 747 family, these are the various aircraft of the 747, and talking about the specifications of 747-800 series, it has 410 feet. The range is about 14,000 kilometers, and length is about 76 meters. So next slide. So in this presentation, we'll be talking about major systems of 747, which are stated as follows. The first one is an auxiliary power system. The second will be LED lighting system. Third will be the cockpit systems and display. And fourth will be the radar system of 747.
Hi everyone, this is Janvi and I'll be presenting auxiliary power systems. So most modern aircrafts have auxiliary power system, which is also known as the APU. It is in the tail of the section and it also has a little exhaust as you can see in the picture. This is because the APU system also has a turbine, so it is to let the heat out. Apart from that, an APU consists of a compressor and a gearbox. An APU basically provides electrical power to the aircraft, which basically illuminates the aircraft, and it is also used for bleed air system and air conditioning. Uh, if we think about it, an APU is pretty important for commercial aircrafts. But if we think about it, an APU is not needed uh, in aircrafts which are not commercial. For example, an aircraft can work without an APU if it is not commercial and if it is a two-engine aircraft. And an APU is not certified to operate above 20,000 feet. And apart from that, it cannot be started in flight. Next slide, please. So talking about Boeing 737 and 747, the APU is located in the tail section, as we can see in the picture. And the APU noise is a very is very loud, and it's quite a problem in especially densely populated cities, which are also quite small. So it can affect a lot of people, especially the ground crew maintenance staff and people living in the vicinity of the airport. There is very little information available about this. Next slide, please. Talking about the starting of the APU, as you can see in the picture, we have a panel, which is basically you can see the switch, an APU on and start and off. Three things are mentioned, and if we turn the switch to start, it will rotate and it will come back to APU on. Once the APU starts generating normal power, it will the LED light behind the APU switch will illuminate, telling the pilot that the APU is running. Next slide, please.
Okay, so let us understand the LED lighting system. LED lighting systems plays an important role in the Boeing 747. We can see many different lights in the aircraft. We have the logo lights, which are placed on the horizontal stabilizer, which illuminates the logos. Then we have some wing inspection lights as well. Wing inspection lights are mounted on the fuselage and are aimed to illuminate the leading edge of the wing and the engine pylons. They are often used during the hours of darkness and the aircraft pre-flight inspection and the illumination of the engine start. Then we can even see there are cabin lights and aisle lights as well. So these lights are basically for the emergency and plus to attract the passengers as well. So moving on to the cockpit displays, Ashwin.
So I'll talk about the main cockpit display. It is divided into three parts: the top view, the middle view, and the lower view. The top view has EICS computer. It is divided into two parts again. First is engine indicating system. It indicates everything related to engines. It shows the engine statuses such as engine power, gear settings, flap settings, cabin pressure, cabin altitude, and fuel levels. It also shows secondary statuses such as those statuses, your checklist, auxiliary power unit statuses, hydraulic pressure statuses. Then we move on to the crew alerting system. The crew alerting system has uh, the pilot maneuvering system. The flight that the aircraft is in a particular flight level of 30,000 feet. So anything can go wrong, either due to the fire, engine failure, pressure drop, or the temperature change. Hence, the pilot need to get the prompt first and the information regarding the issue and the problem first. So the CAS, which is the crew alerting system, shows the alert to the pilot about the issue and gives the prompt to the pilot. Now the middle view has the flight management computer. In this computer, the pilot enters the route. It tells you how much fuel is burned from waypoint to waypoint and tells you the information about the route. It shows the route in a magenta line. So everything is monitored there in the particular flight management computer. And the route in which the autopilot also travels the flight, also maneuvers the flight in which the pilot displays. Next slide, please. Now we have the lower view. The lower view has the many switches are there, such as the electronic switch. These buttons control the power level of all parts of the aircraft. Then we have the fire suppression. The fire suppression, this control the fire extinguisher whenever there's a caution related to any fire. Then we have passenger comfort. The passenger comfort in which the switches control the air conditioning in the cabin and the cockpit. Then we have the lighting, as mentioned by Simmer. All the lightings are controlled here. The beacons, the navigation, the strobes, the logo lights, the taxi lights, everything is controlled here. Then we can see the hydraulic control. This is the main control of the hydraulic pressure that are used to control the control surfaces, such as flaps, ailerons, spoilers, rudder, horizontal stabilizers. And also the deployment of the landing gear is done by the hydraulic pressure control. We have the fuel jettison system also, whenever there's a case of emergency in which the pilot need to dump the particular fuel due to excessive weight and do the emergency landing. It is done by this control level.
So, talking about the radar and navigation system of the Boeing 747, Rockwell Collins, which is a US-based multinational company, provides the avionics system, but it also provides multi-scan hazard detection system, which is one of the first and only radar that determines actual weather hazard, not just determining the weather moisture content. Also, the display system, which is also provided by Rockwell Collins, is a LCD display, which, as talked by Ashwin, such as electronic checklist with cursor control panel, navigation performance, etc. So, other equipment which are provided by Rockwell Collins is the communication management unit, the satellite communication system VHF, which is very high frequency omnidirectional, and uh, distance measuring equipment, automatic direction finder, multi-mode receiver, etc. VOR, as we all know, is very high frequency omnidirectional range. So it is a short range radio navigation. Also, as provided by the Rockwell Collins, a terrain avoidance and warning system is also provided, which tells the pilot about the terrain in front of him. As we can see in the figure, red, yellow, and green markings are done on the navigation panel. the TAWS provides the information regarding excessive rates of descent, excessive closure rates to terrain, and excessive downward deviation or other glide paths.
So there are some interesting facts about the Boeing 747. It takes approximately 90 gallons of paint to paint Boeing 747 completely. There are around 14 stairs to the upper deck. Around 365 switches, dials, and lights are used in the cockpit. If we stretch out the entire electrical wiring of the Boeing 747, it would extend over 150 miles. NASA purchased 2 modified Boeing 747 for space shuttle missions. So thank you, everyone. We would like to give special mention to our professors Sudhir Kumar Chaturvedi and Space Habitat for letting us present this presentation.